Hello everyone and welcome to this video lecture. My name is Ramkumar Sahu and I am from Department of AIML Technocrats Group Bhopal. Today I want to discuss about an important data structure that is stack. This lecture contains overview of stack, basic principles, operations on stack representation using array, stack using linked list, application of stacks, advantage, disadvantage of stacks. A stack is an abstract data type commonly used in most programming languages. It is named stack as it behaves like a real world stack. For example, a deck of cards or a pile of plates, poppins in a bake, biscuits in a bake if we use one end for insertion and deletion. Overview of data structure, that is data structure is used to store data and manage it. It is a non-primitive data structure, it is linear data structure, it is dynamic data structure that we can shrink or expand as per the requirement. It uses one end, that is called top end. It uses a strategy, that is the last in first out. Stack. A stack is a linear data structure that follows a particular order in which the operations are performed. The order may be last in, first out. That implies the element that is inserted last comes out first. It means both insertion and deletion operation happen at the one end, that is called top of the stack. Common operations on stack. In order to make manipulations in stack, there are certain operations provided to us. That is push operation, that means insert an element into the stack. Pop operation, that means remove an element from the stack. Top, that means return the top element of the stack. Is empty, that operation shows that the return true if stack is empty, else false. Size, that returns the size of a stack. Operation on the stacks. First operation is the push operation. It means the add an item to the stack. If the stack is full, then it is said to be an overflow condition. Before pushing the element to the stack, we check if the stack is full, and if the stack is full, top is equal to capacity minus 1, then stack overflow condition, and we cannot insert the element in this condition. Only we can insert elements, otherwise we increment the value of top by 1, that is top is equal to top plus 1, and the new value is inserted at the top position. An element can be pushed into the stack till we reach the capacity of the stack. Here one different pictures that shows the how insertion can be take place in the stack. Initially, first picture shows that stack is empty, then top is equal to minus 1. The capacity of stack we take in here, that is 4. One by one, we take new elements, insert it into stack, and at last condition, when all the 4 positions are filled up of the stacks, new element cannot be inserted into the stack due to stack overflow condition. Pop operation, that means removal of an element from the stack. The items are popped in the reverse order in which they are pushed. If the stack is empty, then it is said to be underflow condition. Before popping the element, we can check the stack to underflow condition. When stack is empty, no pop operation possible, only push operation can be possible in it. If the stack is empty, top is equal to minus 1, then stack underflow condition, and we cannot remove any element from the stack. Otherwise, we store the value at top, decrement the value of the top, by top is equal to top minus 1 and return the stored top value. In this picture, there are different steps that are used to how popping done in a stack. In step 1, there are stack contain all 4 elements. So the top source values is 3. We pop one by one, and at last, when all the elements of the stacks are popped, then the top goes to be value as -1. That means stack is a empty. Declaration of stack using array. A stack can be implemented using an array when maintain an integer array to store elements, a variable to represent the maximum size of the stack, a variable top to track the index of the top element. Initially top is equal to -1. That means empty condition. Here the array representation of the stack shows when element pushed into the stack, the top goes to the one in position up, and when pop operation performed, the top goes to one position below. Can be implemented by mean of array, structure, pointer, and linked list. Stack can either be a fixed size or a dynamic or variable size. Here, picture shows the representation of stack using linked list, where insertion and deletion take place from a single end that is called top. One element that is pushed into the top and pop also from the top. That is the push operation and pop operation performed here. Yes, this one is the pop operation. Now stack works on the mechanism the last inserted item removed first, that is called last in first out. Here are some functions that shows the how this operation take places. That is the first one is the push operation, pop operation, create a stack is empty, and full condition. Declaration of the node or stack in array representation and linked list represented using structure. This one is the stack creation using array and linked list. This one is the push an element into the stack in array and linked list. This is the pop operation that performed to delete an element from stack using array and linked list. Checking for stack empty, checking for stack empty, and this one is the application. That means the conversion of infix to postfix notation. There are three kinds of notation. That one is the infix, prefix, and postfix notation. This shows the infix notation where operator in between the operands. A, B, C are the operands, and asterisk and plus are the operators. Postfix notation shows this kind of operator after the operands is the postfix, and when operator fix before the operands, that is prefix notation. Here infix shows the a plus b is equal to ab plus, and likewise these different infix expressions are given and its equivalent postfix expressions are shown. This also, that is the conversion of infix to postfix notation. Use a stack for processing operator, push and pop operation, scan the sequence of operators and operands from left to right, and perform one of the following: output the operand, push an operator to the higher precedence, pop an operator, and output till the stack top contain operator of a lower precedence and push the present operator. This is the algorithm steps: print operand, as they arrive. If stack is empty or contain a left parenthesis on top, push the incoming operator onto the stack. If the incoming symbol is left parenthesis, push it on the stack. If the incoming symbol is right parenthesis, pop the stack and print the operator until you see a left parenthesis. Discard the pair of parentheses. If the incoming symbol has higher precedence than the top of the stack, push it on the stack. If the incoming symbol has equal precedence with the top of the stack, use association. If the association is left to right, pop and print the top of the stack and then push the incoming operator. If the association is right to left, push the incoming operator and so on. That is the infix to postfix conversion. First, add to the postfix expression, close parenthesis, pop stack symbols until open parenthesis appears. Operators, pop all the stack symbols until a symbol of lower precedence appears. When push the operator, input all remaining stack symbol and add to the expression. Here a very good example of conversion of infix to postfix. That is, expression is given, mathematical expression is given, and after conversion of this comes becomes this in postfix notation. These are the first table contains current symbol that are scanned by one from left to right, and this is the status of stack, which symbol are taken, that is the left parenthesis, and other operators are taken in the stack, and that is the postfix string that are generated after the operation. This is the conversion of infix to prefix notation. Here a proper example is given for conversion infix to prefix notation. We take input in the form of infix notation, reverse the given string expression and convert it into postfix notation, its equivalent postfix notation form, then reverse the postfix notation and convert it into prefix notation. That is our output. Application of stack. There are different applications of stacks, like function calls. Stacks are used to keep track of the return address of function calls, allowing the program to return the correct location after a function has finished execution. Recursion. Stack is used to store the local variable and return addresses to the recursion function. Expression evaluation. Stack are used to evaluate expression in postfix notation, that is the reverse Polish notation also called. Syntax parsing. Stack are used to check validity to syntax in programming language and other formal language. Memory management. Stack are used to allocate and memory manage in some of operating system and programming languages. Advantage of stacks. Simplicity. Stacks are a simple and easy to understand data structure, making them suitable for a wide range of application. Efficiency. Push and pop operation, that means insertion and deletion operation on a stack, can be performed in constant time, that is the big O of 1, providing efficient access to data. Last in first out. Stack follow the last in first out principle, ensuring that the last element added to the stack is the first one removed. This behavior is useful in many scenarios such as function call and expression evaluation. Limited memory uses. Stack only need to store the element that have been pushed onto them, making them memory efficient compared to the other data structures. There are some disadvantages also to be a stack. Limited access. Element in a stack can only be accessed from the top, making it difficult to retrieve or modify element in the middle of the stack. Potential for overflow. If more elements are pushed onto a stack, then it can hold an overflow error will occur, resulting in a loss of data not suitable for random access, limited capacity. These all are the disadvantages of stakes. Thank you for listening.